Hi guys, this is Miss Chocolate. Continue for the first video, I will titrate the known concentration of sodium hydroxide to solve the unknown concentration of hydrochloric acid. Let's start. Remove this one also. The stop room, we start from HCl again. It's already 100 milliliter. So what we should do is add 0.5 saline solution and fill 50 milliliter. You can start with 45 if you want. Okay, so this one, HCl solution, 100 milliliter. I will add phenolphthalein to see the color change when NaOH is added. Yes, 0.5. Then remove. And then again, we start the titration. Water is spirit here. Now we have to add NaOH. We already know the concentration now. 45. Move. You should know the start point, which is 7 milliliter in here. Should not forget this. 7. 7 milliliter. Then we can start. This is just a tip, but this simulation provides the chance to duplicate the apparatus and the solution in the same condition. So for the tip, you can repeat your experiments several times without remaking the solutions. And one more good thing to this is that we can expect the value more in a short time. Like I can try first 20 milliliter. It changed the color, right? So it should be less than 20 milliliter. This is kind of a trick that we can shorten the time of the experiment, but it's like advantage of the simulation. So we can try to use it if you want. We know this is wrong, the 20, this should be less than 20. And in case we can fail again, we can duplicate this one again. And I'll try this time 50 milliliter and see whether the color changes or not. It changes, so it means less than 15 again. So once again, duplicate. Oh no, this one. Duplicate this one. Okay, so I'll try to do 10 milliliter this time. Oh, it's changed again. Then, oh my god. Remove, duplicate. If you don't want to do this, just click 0 point. You just type here and click the pour. It may took more time or less time, not sure. First, I will add 5 first. And then from here, I will add 0.1. So let me see when this color changes. Should be really careful and concentrate, okay? Oh, yeah. Okay, I think it was until 17. I click once more. So it is 17. 17 milliliter. So it is 10 milliliter volume of NaOH added, right? I'm using the same decimal points because the burette has the smallest interval of 0.1. And then using this, we know the molarity, right? This one that we calculated before. And then volume of HCl solution, initial volume. Yes, initial volume. It was not the volume, but initial volume. It was 100.5 milliliter because it was first in 100 milliliter and phenylephthalate 0.5 milliliter. So now we can calculate the molarity of the HCl solution. We'll see. Oh, same with the part one experiment. This is the precise mode, right? So I'm not gonna repeat this again, but you should repeat several times more to get the valid data, more accurate data, okay? Using this data, I will calculate the part two HCl concentration. We will use this famous equation, molarity. M represents the molarity and V represents the volume of the solution. So first, M1 and M2 will be the molarity and volume of the NaOH solution. But for M2 and V2 is the molarity and volume of the hydrochloric acid. So we know that molarity of the NaOH, the M1, is this one here. And then volume of the required titrate, what was it? 10, yes, 10 milliliter. The molarity of the HCl is unknown, and the volume of the HCl, we know the initial volume was 105. We will add this one in V2, right? Here. And this equation is like this. So in here we put 0.9628 and what milliliter? 10 milliliter. Yes, we don't know the M of the HCl. It's gonna be 105. So if we want to calculate the molarity of hydrochloric acid, we should divide times this one first. Well, Debbie, I'm gonna write in here. Yeah, 0.9628 times 10. Oh my god, 10 divided by 100.5 to 8. Yes, it is 8. I think we all know this fact that even though I use 0.9628 in here, this is just for to show the quantifying this the value that I got. So I mean this is the rounded value, but in the calculation you should use the raw value that you got in the calculator. It's the rough value of this 0.9628 in my calculator is 0.9628303.471. You should use this value for the calculation, but just write the rounded value for the only for the answer, okay? So if I do that, 10 divided by 100.5, I got the concentration of 0.0958040146, but if I round it for the first degree to figure, 0.09580. So this is the molarity, the concentration that I got for the HCl. I'm not sure, but if I measure the volume in a precise way, I hope I got the answer. Oh, I cannot just copy paste. 9580. 9580. We'll see track. Yay, we got the answer. Yeah. Well then, you did a great job. Yes, you can print this report. Yeah, this was all about this titration to get the concentration of HCl by unknown concentration of NaOH, which is calculated by titration with solid KHP. It was all about it, and hope you guys enjoy the chemistry simulation. And thank you.